substance that burns things. Okay. In this case, we're going to make cryogenic napalm. Does anybody know what the term cryogenic means?
No.
Cold, right? It means to, yeah, cryogenic. So like, if you cryogenically freeze somebody, okay. So this is isopropyl gas line, yep, for when it's really cold out, like this morning. Okay. And what we're going to do is add some dry ice to this. And the interesting thing about
what do you do?
it's fine. Okay. I think it's fine. So the interesting thing about rubbing alcohol compared to water is it has an extremely low freezing point, right? That's why you put it in your gas line. So it's even lower freezing point than gasoline, which has a very low freezing point. So we'll talk about why that is as we get into chemistry. But this stuff doesn't freeze at 110 degrees. So this is going to be minus 110 degrees in just a minute here. And it's going to be sticky. And so obviously if you got your finger in this, it would just give you frostbite instantly and kill the cells on your hands. That's why I'm going to put on gloves. Okay. And so I will only get frostbite through my gloves. So I'm going to dip a gummy worm, and this is just so you know. Okay, regular gummy worm. Okay, no problem. Okay, and I'm going to put it in this cryogenic napalm here for a minute. No. I have 2 more gummy worms.
Can I eat it?
No one's eating them. So let's give it a second here. Okay, now. Okay, you can hear that it's frozen. I don't know if it's going to be frozen enough to break or not, but it's definitely frozen. Okay. So if I'm gonna hit it, oh, not quite yet. Okay. So we gotta give it a little more time.
It's still edible.
It's still not edible. No, you would not.
It looks good.
You would not want to eat this.
It looks like I'm willing to eat it.
Okay. Put some more dry ice in there. So, I've seen videos of this too where you can freeze flowers and just like shatter a flower. This does not get as cold as liquid nitrogen, right? Liquid nitrogen is like minus 250 degrees. This is just minus 110. We might, you know what, so last year I thought about getting liquid nitrogen, and my father-in-law has some on his dairy farm. And last year I think they brought some into the chemistry lab, I think last year. So maybe if you take chemistry, then you might be able to experiment with that. All right, let's see if this is hard enough to. Whoa!
Can I eat it?
All right, so do not eat it. No. So it completely shattered. So
It's a hard gummy candy.
why?
Question 10.
Yep. Why? Look at question 10 or whatever question it is. Why does this gummy worm shatter now? It's frozen, but why do things shatter when they're frozen?
Because they cold.
Wait, Matt. Vanilla has something else smart to say.
The particles are packed really tightly together, so when they.
So when you hit, that's right. So think about a liquid and a gas. Those molecules are free to move around each other. In a solid, the molecules are very, very tightly packed together. And the colder that solid gets, the more brittle it becomes. And when a hammer hits it, instead of the molecules being able to move past each other, they're very static, and so the material breaks. So it's because as things get colder and more solid, they become more brittle. That's why.